All right. In this video's lesson, what we're going to be talking about are what are called piecewise functions. So a piecewise function is a function which is comprised of multiple expressions or pieces over separate intervals. So rather than just having kind of one single expression to represent the function, you've got kind of multiple different ones, different pieces that each have kind of a different interval that they are over. So we're going to take a look at a couple examples. We're going to look at first how you evaluate a piecewise function, and then secondly, how you graph a piecewise function. So to start off with, let's just talk about evaluating. So when you're evaluating a piecewise function, for number one, we're going to talk about f of 2. The first thing you have to decide is where the number 2, which remember is your x value, fits into these intervals right here. And so the first one says where x is less than or equal to 1. Well, 2 is not less than or equal to 1, so it's not going to be the first one. The next one is where 2 would have to be between 1 and 3. Well, that is in fact true. If you put 2 in for x, 2 is greater than 1 and less than 3. What that tells you is that you're going to use this expression to evaluate. Now in this case, there's nowhere to plug 2 in. The answer is actually just going to be 3. Let's take a look at another example of this. Let's take a look at where we have x is negative 3. So negative 3. We first check our first interval x less than or equal to 1. Is negative 3 in fact less than or equal to 1? And actually it is. So we're going to take negative 3 then and put it in for x in this expression. So that would be negative 2 multiplied by negative 3 minus 2. Which then becomes 6 minus 2, which is 4. All right, let's take a look at one more example here. So we've got f of 3. So 3, obviously not less than or equal to 1. You also have to be kind of careful here because 3, while it is more than 1, technically 3 is not less than 3. However, 3 is greater than or equal to 3, which tells us that we're going to use this third expression to evaluate. So we're going to take negative 2 multiplied by 3 plus 6, which becomes negative 6 plus 6, which is 0. So yeah, really with piecewise functions, evaluating just comes down to figure out which interval it fits into and then use that expression to evaluate. All right, let's talk a little bit about graphing. And for the most part, we're going to be graphing using a graphing calculator. However, I do want to show you kind of how to make sure, especially your endpoints are clear, kind of what you want to be doing. So number 4, we've got h of x is equal to, you've got your two expressions there. One is where x is less than or equal to 2, and the other is where x is greater than 2. Let's start with the one where x is less than or equal to 2. Basically what that means, if you think about it, is that this piece of our graph is going to be basically anywhere that x is less than or equal to 2. So it's going to be somewhere kind of over in this shaded region. So what we're going to want to actually do is kind of start wherever x is equal to 2 and then draw our function out from there. So let's figure out what's going on where x is equal to 2 for this particular expression. So if you plug into negative 3 multiplied by 2 plus 2, write that a little bit better here for us. Okay, that becomes negative 6 plus 2, and that becomes negative 4. So we're going to put a point at positive 2, comma negative 4. Now, there are two different types of points that you can use. Notice that I've used a filled in point. That's because anytime you have less than or equal to or greater than or equal to, you're going to use a filled in point. Anytime you have less than or greater than, you're going to have an open point. As for the rest of kind of that piece of our graph, it tells us that our slope is negative 3. However, we cannot do kind of our normal slope where we would go down 3 to the right 1, because then you'd be drawing a graph going to the right. And we want where x is less than or equal to 2, meaning we want it to be going to the left. So instead of going down 3 into the right 1, we're actually going to go up 3 to the left 1. Up 3 to the left 1, and do that a few different times. And then we can draw in our line going through those points. Oops. All right, so there's kind of our first piece of our graph. For the other piece of our graph, we've got the expression 1/2 x minus 4, where x is greater than 2. We're going to do kind of the same thing we did to start our other piece, is that we're going to just figure out what it looks like at our endpoint. So we're going to take 2, plug it in for x. 1/2 multiplied by 2 is 1, and 1 minus 4 is negative 3. So we're going to put a point at 2, comma, negative 3. This time, though, because it's going to be strictly greater than 2, we're going to put an open point at that value. I'll zoom in a little bit here. So at positive 2, negative 3, pretty much right on top of our other point, we're going to have this open point for our graph. And this time we can actually use our slope like normal. So our slope was 1/2, which would tell us to go up by 1, to the right by 2, up by 1, to the right by 2. And then once you've got a few points in there, you can draw in the rest of your graph. All right. Now, an easy way to check yourself and a resource that I'm going to make sure that you have available to you, both in any homework and on the test for this unit, is going to be that you can use a graphing calculator to kind of check. Now, I'm going to share with you Desmos graphing calculator on this particular video. However, if you want to use your own graphing calculator, I'll be making a separate video that shows you how to type a piecewise function into your graphing calculator. Let's go ahead and go to Desmos, though, for right now. All right, so in Desmos, we're going to start by typing in our first expression, which was negative 3x plus 2. Then to type in that we want this only where x is less than or equal to 2, we're going to go in and find these curled brackets. Or on your keyboard, find those curled brackets. They're kind of near the enter button if you're looking for them. And then inside those curled brackets, we're going to type in where x is less than or equal to 2. Now, one thing you'll notice about Desmos is that you're not going to get that kind of filled in point like we were talking about. Notice that it just kind of ends at that value of 2. So you're going to have to know kind of what point this is kind of right down here. So that's the part where you do need to remember a little bit by hand, but for the most part, the graphing calculator can definitely help with that. All right, let's take a look at our other expression that we were going to be graphing. So our other expression was 1/2 x minus 4. And again, we want for that to only be where x is greater than 2. So we'll type that into our curled brackets, x greater than 2. And then if you notice, our graph looks just like it did that we graphed by hand. Again, the only thing that you're not going to be able to see on Desmos or your own graphing calculator is what type of points are at the ends. So that's where it's important to know graphing by hand, to be able to know kind of what these points are right in here so that you can create an accurate graph or pick whichever graph is appropriate. Now notice that vertical line test still works on this graph. So even if the only spot that you might have been curious about would have been kind of these points right here, but notice that if you draw it through those points, technically it only crosses through one. The other point's an open point, so technically it doesn't actually cross through any points there. And so the vertical line test still works. This is still, in fact, a function. All right, let's take a look at another example, this time where we've got a little bit more going on. We've got 3 expressions instead of 2. So on number 5, we've got f of x is equal to 4, and then x squared, and then 4. Okay, so starting with our first expression, it tells us that f of x is 4, where x is less than or equal to negative 2. Now remember, 4 just means that it's going to be constant, meaning it's going to be a horizontal line through y equals 4. And we want that everywhere to the left of negative 2. So if we go to negative 2 up to 4, we're going to start by putting a filled in point because, again, we had less than or equal to. And then remember, it's constant through 4, so we're just going to draw in a horizontal line through y equals 4. So let's go ahead and do the same thing with our other y equals 4 on the right side. So that would be at positive 2, comma 4. Again, you had greater than or equal to, so that's the reason for the filled in point. And then here's the rest of that graph. Now the tricky one is x squared, and it tells us that we want to do that where x is between -2 and +2. So here would be my suggestion to you, is just go ahead and make an xy t-chart. And for the x values, you know that you want them to be between -2 and +2, and we'll just use whole numbers, -2, -1, 0, 1, 2. And then for the y values, it tells us that we're going to take x and square it. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Now, because you may have noticed that these are not less than or equal to signs, strictly less than, that means that our points on the ends, the -2 and +2, need to be open points. So let's go and graph these. Our first point was at -2, 4, and that's actually where we already had a point. So really what's kind of happening here is you've got kind of an open point around a closed point. And then -1, +1 is just going to be a normal value, normal point, 0, 0, 1, 1. And then lastly at 2, 4, again, open point around a closed point. And then a quadratic graph, as a reminder, is the U-shaped graph. It looks something kind of like this. And here would be our piecewise function. So let's go ahead and take a look at Desmos, make sure that we kind of get the same graph when we do it that way. So our first piece was +4. So that was, and I'll probably have to type in the y equals for this one. So y equals 4. And again, we'll use our curly brackets to say that we want that where x is less than or equal to -2. All right, and then we had another piece of our graph that was also y equals 4. And then this one was again where x was greater than or equal to +2. So there's our first two pieces. Our last piece was y equals x squared. And again, that was in between the two values. So that was from -2 less than x less than 2. So yeah, it does in fact give us the same graph that we did by hand. Again, notice that the only thing it's not going to show you is how those endpoints work for the different pieces. But a good way to check yourself, and a good way if it's multiple choice to try to figure out kind of what's going on with your graph. So make sure and use those resources that you've got available to you. Like I said, in a future video, I will be showing you how to use your graphing calculator, your TI-83 or TI-84 to graph piecewise functions. Until then, have a great day.